Hi guys, how are you? We're going to do a quick little video on one of those classic questions in similar triangles that might be familiar with you in the upcoming assessment task. So it's the similar question that we did last week. How tall is the silo? So like we did out in the ovals, we got our silo and we need to get a group of people. So we've got our friendly teachers, Mr. Haylock and Mr. Langhans, to help us create our similar triangle. So you can see here Mr. Langhans standing in there in line with Mr. Haylock and the top of his head and the top of the silo, which is giving us two really nice similar triangles, one big, one large. So this one has been enlarged to make the big one. Now, so the next bit that we need to do is, well, because we can't climb up that tower, what we can do now is actually measure a few things except for this. So what we've got here is we can measure the distance from the tower, the silo to Mr. Langhans, which is 50 metres, and from Mr. Langhans to Mr. Haylock is only 9 metres. We now can measure the height of Mr. Langhans from the top of his head to the ground, and we can got all that information, but we still don't know about the silo. So now we should have two perfectly good similar silo to where that happens to be 59. Note here that you can see that's 50 metres, and there's only another 9 metres to take. To make that a triangle, we have to add those. There's a real common mistake that occurs. People just use the 50. Here we've got the 59 metres here, and then we've got our little triangle from Mr. Langhans to the Mr. Haylock. It's only 9 metres. So how we can calculate this? Now let me see if I can get this tool up so I can draw. It's not letting me move it. So that's all good. So we actually don't know this side. Now blue was... Anyway, I like to start off with the unknown as the top. Now we know that this side of the triangle has been enlarged from this side of the smaller triangle. So I can make that now divided by the height of Mr. Langhans. And that is got to equal the size of our large triangle. So I'm going back to the large triangle, and that has been enlarged by this one down here. And now I've got my scale factor. This is so much harder than it really looks. Scale factor ratio equation all written, ready to go. Now what we now need to do now is to solve for x. Now if I have a look at this side over here, that's quite easy. I can plug that into my calculator, and 59 divided by 9 is 6.55. And I haven't done anything to my left hand side yet. So how do I get x by itself over here? I've got x divided by 1.65. How do I get rid of that 1.65? Because it's a divide, I do the opposite. 1.65 times. Golden rule of mathematics, what you do to one side, I have to do to the other. These guys cancel out, leaving me with x. Now, we've got our x to equal 6.55 times 1.65 happens to be 10.82. Looking at my calculator here, meters, don't forget units, and that's my answer. And does that seem like a reasonable solution? Well, if Mr. Langhans is 1.65 metres, it's definitely going to be taller than that. That seems like a reasonable solution with the values we've got.